Hello and welcome to another session of Groundbreakers Live. I'm your host Javed Mohammed. I'm very honored to have with us Nikhil Nanivandekar. Nikhil, welcome.
Hi, Javed.
So I
Thanks.
hope, hope I got your name almost, but not quite right.
Oh, that was perfect.
uh, so Nikhil is a Java champion as well as the director at the Bank of New York Mellon. So I don't think that's New York in the background, but you want to tell us where that is?
It's actually those are actually Grand Tetons. I
Okay.
moved from Utah to Texas with the new job, so I
Okay.
still miss the mountains. So it's always good to have them. I
All
mean, we
right.
can't visit them right now, right?
Okay. So you're going to be presenting at Dev.next, obviously, which has got postponed to the fall. So the two presentations. So maybe we start off with your first presentation and just kind of give us some insights into that, getting started with Kafka. So you want to tell us a little bit about what Kafka is and why it's important.
Sure, sure. So yeah, I have two presentations at Dev.next, and both of them are around getting started. So the first one is getting started with Kafka. As everybody knows now, Kafka is used as pretty much a standard, messaging platform to send and receive data.
Mm-hmm.
And uh, the way this entire presentation was formed was because I was trying to learn Kafka and I was using Kafka in my day-to-day job, and I realized that there were a few gotchas, that would be super helpful if someone would have like told them to me instead of after my trials and tribulations of multiple days.
Uh-huh.
If someone would have just given them to me in 1 hour that, hey, you need to do these 5 different things and things just work, because that's literally how Kafka is like. As long as everything is configuration based, as long as you have all your configurations correctly, as long as you understand how the system behaves, things just work. So I decided to write this talk, and I have been presenting this talk for at least a couple of years now, and each time I present it, it's completely different because I don't have a presentation or anything. I just have an agenda, and the agenda is covering what are the components of Kafka and how Kafka works.
So
The con
perhaps we can just pause there. So
Yeah.
what are some of the key components of Kafka?
Sure. So the key components of Kafka are Zookeeper, the Kafka broker, the Kafka producer, and the Kafka consumer. Now, this is where things become interesting because you can only explain so much theory by just talking. Most developers just love to see it work. So I switched to a direct live demo, and from there on, it's the content is pretty much driven by what audience wants to understand, and like what feedback I'm getting from the audience.
Mm-hmm.
And what I cover every single one of these aspects, like how is Zookeeper playing a role in the whole Kafka ecosystem, then what is a broker, then I bring up multiple producers, multiple consumers, I get them to interact with each other, and I show the audience about how Kafka works fine even in what situations and what are the
So
nuances. Yeah,
perhaps maybe that's a good segue.
yeah,
So you mentioned before that Kafka is a messaging system. So is that
yeah.
a messaging system like for microservices or like containers? Like what? Can you give us an outline of that?
Sure. I will say Kafka is used as a messaging system, but essentially, or just to be pedantic, Kafka is nothing but a transaction log. It is similar to a database transaction log, and it is extremely super smart. The way they have designed the whole technology is because
Mhm,
now we can use Kafka
mhm,
for as a messaging system between two different applications. So now imagine this: you had, a very like heavy payload being communicated between two different systems via microservices. So let's say I needed some data from Javed's system, and let's say that like in order for me to get the data, it
mhm,
was going to take, let's say, 1 second, right? Now what traditionally might happen is till that data is pushed, Javed system can't do anything because everything is synchronous, right?
Mhm.
With Kafka, the way it's designed is the producer and the consumer are completely decoupled. So the moment data is produced from a system, it gets pushed onto the Kafka queue, and the consumer can consume at the consumer space. So that's why, because of this sort of decoupled
Mhm.
behavior, and as well as fault tolerance, it is now used as a messaging framework in order for you to like transmit data
Mhm.
between multiple systems.
Okay.
um, the
Oh, sorry, go ahead.
yeah, the other salient point of this is that with a REST service, if let's say you had multiple consumers who needed the exact same data, all
Mhm.
of them will call the exact same REST service and get a copy of that same data.
Mhm.
But the producer will have to still do pretty much the same work in order to create the data. What Kafka lets you do is the producer can produce it just once, push it to the topic, and each of the consumers can consume at their own rate. So here we have drastically reduced the amount of work that producer will have to do. So again, all of this sort of like helps in creating and devising a nice Kafka ecosystem.
Okay. I know I won't make you repeat your presentation, but
No,
you said there were lessons learned. Is there
yeah,
like one takeaway you want people to kind of go with? Like, is like, there's things to do and there's things to avoid. Can you pick one and just share that?
yeah, the most important thing is make sure your system is idempotent. uh,
Your
so
system is?
idempotent.
Okay.
So an idempotent system means that if you play the exact same, and I'm going to call it in Kafka terminology itself, if you play the exact same message over and over again, the outcome of that should be the same.
Mhm.
Because the producer might produce the same message, but on a consumer side, let's say you consume it more than once because of a system going down, because of infrastructure being unavailable, because you asking Kafka for the
Mhm.
same message again, etc., etc. So on the consumer side, it's
Mhm.
always a little bit more work, but you have to make sure that your system is idempotent. So if you consume the exact same message multiple times, still your system does not get affected.
Okay. All right. Let's segue into your Spark presentation. So getting started with Spark. So give us a
Yep.
segue into that.
So again, Spark was another framework which I learned on the job. And oh, my background is I'm not a software engineer. I did not learn how to code in college or in school. I mean, in school we had like really basic programming classes, but
Mhm.
I did not go through the academic system of learning how to do software programming. I'm
Uh-huh.
a mechanical engineer by education.
Wow.
So thank you. So on when I started actually switching into a career of being a software developer, the biggest problem that I had was how to get started with anything.
Uh-huh.
So that's the reason why most of my talks generally revolve around getting started with some or the other technology, because
Mhm.
I try to learn it with, I try to learn it as if like I was the Nikhil of 2012 who does not know anything
Which is
about
great.
software.
That's a
Yeah,
big help. Uh-huh.
yeah. So with Spark also is the same thing. Now Spark is a framework which is mainly used for big data analysis. So um, it's sort of the better version or the upgraded version of MapReduce. So when we are dealing with big data solutions, the biggest problem comes is not just multi-threading, because let's say you have millions and millions of rows and
Mhm.
you need to process those millions of rows, right? If you have just one processor, you can, let's say, have like 100 threads on that one processor, but at the end of it you still have to process those million records. Where you get the most amount of benefit is if instead of having one processor you have multiple processors and you
Mhm.
distribute the data.
Okay.
So Spark helps you in actually doing this big data analysis or big data computation in a distributed environment. uh, so that's pretty much where Spark lends its power.
Okay. And is there a good use in terms of a good use case you can share with us for Spark?
The the most use case which I end up the most common use case which I end up like showing in my demos is, let's say we were giving a list of words, and then we have to sort of figure out which letter was used the most number of times in let's say and when I say a word, let's say you had multiple books, right? Like if you had to analyze all those books and figure out like how many times a particular word was used, etc., etc. Now they can definitely be done in a normal system, like which with a plain old Java system,
Mm-hmm.
but with Spark you just get more performance and
Good.
you get the repeatability.
Okay. And is there one lesson you want to share about things to avoid?
Yes. So Spark becomes extremely interesting because by default Spark is always lazy. And when I say lazy, it evaluates in a lazy fashion.
Mhm.
And the salient point of lazy evaluation is it waits till the very last step for it to evaluate anything. So whenever you're doing aggregation operations, it always causes a performance bottleneck because of this lazy aspect of Spark. But there are also important reasons why it Spark is lazy. So always remember, Spark evaluates everything in a lazy evaluation fashion. So if you don't see data, like, it's mainly because something has not been evaluated correctly.
Uh, Well, Nikhil, they both sound like great presentations,
Thank
and
you.
hopefully, would encourage the viewers out there to check them out once Dev.next takes place. So
Yep. Thanks a lot, Javed. Yeah.
thank you.